today is about vocabulary because we need to take a look at all the properties of two parallel lines when they're crossed by a transversal. Understanding and knowing these properties will help you solve all of the problems that involve parallel lines and transversals. So let's get started. Now, first of all, you should notice that these two lines, this blue one and this tealish one, have these strange little arrows on them in black. That represents that they are parallel. So that's how we represent in a picture, in geometry, parallel. We cannot assume that they are parallel without the symbols. The purple line is a transversal. A transversal is a line that crosses another line. Well, there's this slanty line, and it's crossing two parallel lines. It's creating some properties. Well, first of all, it's creating exterior angles and interior angles. You can kind of tell by the names, but I do have some examples for you to determine what they mean. All right, so let's take a look at interior angles. We have an example, 3 and 6. So 3 and 6. They're inside, interior. And that's really what it means, inside angles. Well, from that, hopefully you can deduce that exterior are external angles. So 1 and 2 are on the outside of our little parallel lines. Okay, some other words we need to take a look at. Same side. So let's understand what it means, same side. Same side of what? Okay, so an example is 1 and 5. 1 and 5. So what are they on the same side of? Well, they're not same side of one line, because they're on different lines. They're on the same side of this transversal. So not just this blue line, line 1, or this teal line, line 2. They're on the same side of a transversal. Alternate angles, example angle 8 and angle 3, 8 and 3, they are on different sides of this transversal. Different sides of the transversal. And the way I like to remember it, and I don't know if this is helpful for you, maybe it is, but the word alternate, I always think about alternate endings for movies, and that means a different ending, so different sides. Hopefully that helps. Okay, so that's some terminology. Let's take a look at some other things that this image can give us. This image gives us linear pairs. Linear pairs are two angles that form a line. So for example, angle 1 and angle 2. They form the line L1. Angle 1 and angle 2. We also have angle 2 and 3. These two angles form the transversal straight line. Okay? They are supplementary. Supplementary means they add up to 180 degrees. Linear pairs, lines are 180 degrees. So when we add 1 and 2, or when we add 2 and 3, they should add up to 180. Okay. Next, corresponding angles. Corresponding angles. Well, let's take a look at the example first. Measure of angle 2 and measure of angle 6. 2 and 6. Well, they are on the same side. Well, that's something we can see. And one is an exterior, one's an interior. So that's a little bit different. But what I do notice that's also the same, other than them being on the same side, is that 2 is on the same place where 6 is. It's just on line 1, and 6, oh, there's our familiar bell. Okay, and 6 is on line 2. They're in the same spot. That's what corresponding angles mean. Angles that are in the same spot at each intersection where a straight line crosses two lines. When the two lines are parallel, like we have here, the corresponding angles are equal. So 2 and 6 have the same measurement. 3 and 7 have the same measurement. 1 and 5, 4 and 8. So once you find out angle 1, you can fill in angle 5. That's two angles filled in right away. You can continue filling them in based on linear pairs, but there's an even easier way to fill out the rest of them, and that's using vertical angles. This is a term that we talked about before talking about parallel lines. Vertical angles happen when two lines cross each other, so like right here, and they form four angles, and these vertical angles will be across from each other. So 5, 7, which I wrote for the example. We have 6 and 8, 1 and 3, 2 and 4. They're vertical angles. They have equal measurement. So once we know angle 1, not only do we know angle 5, we know 1 and 3 because they're vertical angles. And since we know 5 and 7. They're vertical angles. And from there, it's so easy to find out 2, 4, 6, and 8 because they're all supplementary. They must add up to 180 degrees. So here's the official definition. Vertical angles are angles created by two intersecting lines. Angles opposite each other have the same value. Okay, I hope this little vocab review has helped you. I do plan on printing this out. If you would like a copy of this sheet, ask myself, I'm in room S134, or your supervisory teachers. I will provide them with some copies. Have a wonderful whatever time of day it is.